Welcome everybody. Welcome reInvent. It's an absolute pleasure to be here today, and I hope you had a fantastic first day of reInvent so far. I've heard all great stories already from folks traveling to 4 or 5 different casinos. Probably your last session today, but for me, this is my highlight, of course, and I'm really hoping that by the end of this session will be your highlight as well. And that's because we have a fantastic topic to cover today: transforming integrated diagnostics. How can we improve healthcare and quality of care for patients if we make it easier to access the right data and break down the data silos? And it's really cool because we're not just talking here from an AWS perspective about pure technology and how things could be done in theory, but we're also having our partner Philips on stage to help us explain how they're building their solutions to actually drive that clinical care for patients and physicians in the field. And we've got a great team with the health imaging team joining me, Jared Nix, Wilson Toe and Predrag Angelowski from Philips. And then my name is Sam Kuhl. I'm a senior solution architect here at AWS, supporting our healthcare customers like Philips. And whenever we start anything within Amazon, we always work backwards from the customer. And within healthcare, that's a fairly simple customer. It has to be the patient. Even if it's directly or indirectly, it always boils down to how can we best serve our patients and provide the best possible outcomes for them? And there are a couple of challenges in healthcare that make this more difficult. And these are all probably known to you. If you read the news, you've seen the stories about the rising cost of care, about our aging population, the cost of medication, and more complex disease states that we're treating that are taxing our services in our healthcare system. And then disparate data silos. As we've moved from a paper-based system into an electronic system, we've done so by moving it one step at a time, creating all these solutions that create different data silos. And whilst we have moved over, it's now up to us to break down those data silos. How can we take the next step and integrate it all? And then shortages, not just on staffing, but on medication, on supplies. But staffing is a key one that I want to call out, because we see all these news articles about nurses, specialists, physicians not having the time to actually work with the patient. How can we give them the time back to really focus on delivering the right quality? And there's a great quote to provide a little bit more substance to that. And it's from the Philips Future Health Index. And it says that 77% of healthcare professionals across almost 2,000 surveyed globally, so the vast majority, see a near 10% loss of productivity by not being able to access the right data. At reInvent, you'll see all kinds of talks about Gen AI, how we're transforming industries. But if I look at this, we're still losing so much productivity simply not being able to access the right data. Such a simple problem, you might think. But then you have a deeper look at medical care and all the data that powers it, and it's incredibly complex. It's not just one type of data, it's multiple modes of data within different spaces. It's EMR data, it's laboratory data, all from different systems. And even within the imaging space, it's all types of different data, whether you have radiology or pathology or cardiology. And then as we ease more and more towards precision medicine, take the next steps in our healthcare system, we're going to bring in more and more genomics to complete the entire picture. And what we want to do with breaking down those data silos is move away from point solutions that we built around a specific type of data or for a specific specialism, and build an integrated shell of data that's patient-centric, that any physician can tap into and get the right data as they need it. And I want to take one example that's key to how we're innovating and how Philips is innovating together with AWS, and that's pathology. And pathology is incredibly cool for so many different aspects. It's very cool from a science perspective. The usual flow, for those who are not familiar with pathology, it's usually used in cancer care, is that you take a biopsy. You take a little piece of tissue, you send that over to the pathology lab where it's prepared, sandwiched between a glass slide as a thin sliver of tissue, and then looked at under a microscope. And the pathologist can from that distill, does a patient, based on this sample, have cancer? What type of a cancer are we looking at? How advanced is the disease? And what type of treatments might work best? Or what type of treatments might not work, making better outcomes for the patients? And all of that data gets collected, aggregated with all the other data that's already collected within lab systems, patient history, send over to the treating physician, who then makes a definitive diagnosis. And it's incredibly cool to look at, both from a scientific perspective and a healthcare perspective, but also from a technology perspective, because digital pathology in itself is going through an entire evolution, breaking down across multiple steps. Across all of these steps, it's actively growing. And currently, we see still that most of the healthcare institutions are microscopy pathology based. So they're still using the traditional setup that's labor intensive. This is all manual to some extent. It's limited options for automation. And because it's purely based around glass slides, there is some loss of data quality over time. So that's why we're slowly starting to move toward digital pathology. We're still in very early stages, and Philips has been a great pioneer in that, where we essentially move from a microscope to a super high resolution camera. And instead of looking through a microscope, we look at pixels on the screen. And that has a lot of potential, because now that we have data, we can reason on top of that. We can let computers run ML, do an automated analysis, or even have multimodal data be collected and presented into one view for the clinician. And then the next step to evolve further is, of course, opening up the data and unleashing the full potential. And that's in cloud pathology, where we no longer are confined to the limits of the healthcare institution, but we break it open. And we make it accessible for clinicians across country, state, international, to be able to collaborate or build research clusters where we can collect the data across various domains, various healthcare institutions to drive forward cancer research or develop new machine learning algorithms to better predict and diagnose. And of course, once you're in the cloud, you can take advantage of so much more than just a solution by using all the different services from AWS. And that's roughly how we see that the cloud plays a role within that integrated diagnostics vision. If we zoom out a little bit again and take a broader view, there are about 4 pillars that we can define: interoperability, unified access and compute, and value-added services. And interoperability really speaks to the essentials within healthcare. We're always going to have all the types and modalities of data. So how do we integrate them? We already have the standards. But how do we actually make it work as one unified data set? How do we properly make this work together? And that's why we've built all of our different services on AWS specific to the healthcare industry, and how we've all those partner solutions to be able to quickly build a data foundation. Leveraging all of our storage services to be able to open up the data, whether it's small volumes or massive volumes, and then layering on the compute to be able to easily transcode, stream, access, and process all of the images or data being collected. And then the core of it is moving beyond that into value-added services. And that's the power of the cloud, bringing together all of our partners and solutions and services to be able to layer on more and more value, whether it's AI, big data analysis, whatnot. And if we zoom out from there a little bit and go into an architectural perspective, this is what we see a lot of customers build nowadays. And this is a very simplistic view of what any medical imaging setup on the cloud could look like, whether it's pathology or any other different type of ology. And essentially, there's a couple of key components. It's a flavor of compute, some flavor of storage, and a database to be able to capture the images, process them, store them, and manage them. And we see that over and over again. And there are a million ways to architect around this, and there's probably good choices, less good choices, and every customer makes their own to create their own basic foundation. And then on top of that, we start to layer all of the value-added services, the great UX to make it simple, the generative AI to add value, your custom models to be able to add differentiation. And repeating that same foundation every time again is what we call AWS undifferentiated heavy lifting. It's creating the same foundations over and over again that don't differentiate your offering from any competitors. And that's not where we want our customers to focus. And that's why we focus on building out different services to help accelerate that. And that's why we built AWS HealthImaging. AWS HealthImaging is a purpose-built service as a DICOM store on AWS to be able to take away all of that complexity, not having to build your own anymore, not having to build your own anymore for each and every product that you have within the imaging space, but take the advantages of a managed service that handles everything for you. And I've listed a couple: pixel, metadata, encoding, decoding, DICOM web as a vending mechanism. And there's so much more within that. But the core of it is that you can directly onboard onto a managed service that takes away the complexity so that you can focus on what's important. those value-added services and components, building out what makes your product differentiating and what really drives forward clinical care and how you can really help patients be better. And we can do that not just across one data set, but we can look at it from a multi-ology perspective, whereby we're not looking at just one type of data, whether it's pathology, radiology, cardiology, but once we have one common data set or data platform, medical imaging, on the cloud, we can then start to leverage that and unify it and have that integrated foundation to build upon. And I think it's worthwhile to dive a little bit deeper into this. And that's why I'm really pleased to have our next speaker to be able to talk to you about AWS HealthImaging in more detail. Please give a warm welcome to Jaron Nix, our product manager for AWS HealthImaging.
Hi, everybody. I'm Jaron Nix. I'm Senior Product Manager here at AWS. And every day I work with partners like Philips to make medical imaging in the cloud faster, more cost-effective, and vastly less complex. Today I'm going to run you through an example of how we can help customers like Philips who work with petabytes of medical imaging data to make their cloud workloads more effective. The basic challenge in medical imaging is this. You need images from a specific patient. Let's say you have Alice and you have Bob, and Bob's data is related to other data. So you want Bob's biopsy data from pathology, and you also want to pull historical data, such as the T2 MR, from some time in the past. Ostensibly, this looks relatively simple, but there are two implicit requirements. Your data needs to be loaded in under a second, regardless of how long in the past it was required. And you need to acquire this data across petabytes and hundreds of millions or even billions of images if you're operating at Philips' scale. What we think of as a medical image is typically a series of images, and these are images that are related to one another through metadata. Metadata can be patient name, the date by which it was acquired, the modality that acquired it, and there's a lot of other clinical context in metadata. There's hundreds or thousands of attributes that come with each of these images. You can have everything from the voltage used or the table height, and this provides radiologists or physicians in general important clinical context. What you're actually seeing on a screen, if you're a physician, are files stored in a data center somewhere. And the reason that these are stored as files, and separate files at that, is because DICOM is a relatively old standard, 30 to 40 years now, and it was originally designed as a network standard. How do you send data between modalities, to golden copy storage, to the viewports of a physician, and then between institutions? We've co-opted this standard to store this data, and this has presented some complexity. So CT scanners typically gather data incrementally. They reconstruct slices, and as that data is prepared, they're sending it to PACS. So I'll run through a few examples of how this can get quite complex. You have your oldest modality of digital radiology. You have X-ray. So let's say that every study, so every time that you visit a hospital and you need data acquired, the X-ray is typically a lateral and a frontal view. So a chest X-ray is a great example of this. You have a few files that are all related to each other, and this is all the physician needs in order to have the comprehensive view of the study that was just acquired. More modern modalities, volumetric data like PET, CT, MR, these are hundreds of images, and the study can often combine both. So PET, CT is a common dual modality study, and the data gets bigger. Hundreds of files, all related to each other, all stored in individual objects in a cloud data store or as files in a file system on premises. And then you have more modern modalities like digital pathology. As Sam mentioned, it's super cool. It's gigapixel images. So you're imaging cancer tissue specimen, mounting it on a glass slide, and imaging this data at micron resolution. And this is important because we'll touch on this throughout the presentation. The cardinality of data is there's less files, but these files are huge. They're typically up to 4 gigabytes per file, depending on the resolution that you are imaging the tissue. And each file contains 100,000 or more images, especially if you're imaging at 20x or 40x objective magnification. And this presents a challenge. How do you get specific data contained within that vast image to a client for a physician to review, a pathologist to review, in under a second? Here's what's happening in a microcosm. So you need to find Alice's CT scan acquired in September. Here are 4 files, and we will walk through how the DICOM standard would have you navigate this data. So we can very clearly see these are 4 different images, and from our past example, we know that 2 of these belong to Bob. So what we can do is we can read the file and look in the metadata header, because in DICOM, metadata and pixels can never be separate. All images must come with the important clinical context. We can look at the patient, and we can tell that that is Bob, therefore it does not reconcile, and we can move on. And we iterate down the hierarchy. We look at the study, and these 2 might be the same. For example, Alice could have visited the hospital and had a chest x-ray taken just before she was laid down into a CT machine for imaging. Then we drill down further into the metadata hierarchy, and we match at the series attributes. We can tell that one is an x-ray and one is a CT. But the problem doesn't quite stop there, because CT data, as I mentioned, is volumetric. And this metadata will tell you that there are 500 more instances, for example, in your universe of data. And this is across, again, millions of patients, petabytes of data, potentially billions of objects. So how can you give a physician the data they need fast and without breaking the bank in terms of cost? I'm going to walk you through a sample architecture, and this is typically how our customers are approaching it. This is a DIY architecture and is intended to represent the average approach to this problem. We start with S3. So S3 is a great product for storing bytes and with high durability and retrieving them. But the DICOM resource hierarchy is what's difficult. It's relating the metadata to the patient and then providing the fast access to the pixels. How do you know which of these objects belong to which patient and which series? So you might start with Lambda, and you would have Lambda detect with Event Bridge new objects written to the bucket. Lambda would grab the files, parse the metadata headers, and insert them into a relational database like RDS. But RDS isn't quite sufficient to navigate this hierarchy. For example, John Doe and Doe, John are the same patient. RDS will not understand that, but a managed service like OpenSearch will. It provides semantic search. Let's say you have that patient name that needs to be reconciled. You might use serverless services like Lambda and step functions to grab the data that needs to be reconciled, edit the metadata headers, and upsert the objects in the bucket. Again, medical imaging has been digital for 30 or 40 years. Much of those images are compressed in ways that are no longer compatible with web browsers. A lot of your pixel data may have been corrupted. It's an unfortunate part of storing this data for 30 or 40 years. You might use Fargate to ingest this data, and what we mean by ingest would be to detect whether pixel data has been corrupted. If so, notify and then build software that could correct that. Also recompress legacy data. So for example, uncompressed data from decades past or JPEG baseline or other data may need to be in a more modern compression codec like high throughput JPEG 2000 or JPEG 2000, for example. And then, of course, you need APIs for interoperability and data access. And you would use EC2, API Gateway, verified permissions. This is the most basic architecture that presents a sufficient data management layer for medical imaging in the cloud. And remember, this is just the data management layer. Business and application logic still need to be built on top of this. And when we see this architecture being repeated across all of our customers, we start to question whether this is the right experience, and we work backwards from the customer. And this undifferentiated heavy lifting that Sam alluded to is probably not the right customer experience for these repetitive workloads. And what is the answer is potentially a managed service, a domain-specific managed service like AWS HealthImaging, which helps customers automatically organize, normalize, harmonize their data, and stream that data with low latency and standards-based API interfaces. This replaces the S3-based architecture. It is intended for golden copy storage of medical imaging in the cloud, and we provide this bundling of services. For example, ingest, you have petabytes of data. You need to get it into this data store fast. We can eat petabytes a month of data. We also have STORs for synchronous writes to the data store from modalities. We present rich data. We present rich search for clinical data, as well as data management APIs, and of course, fast retrieval with standards-based interfaces. And here's what's happening under the hood. Data from S3 is being ingested into the service, similar to the architecture we presented earlier, and metadata is automatically being populated into search indexes. Image frames are being recompressed, they're being parsed and given unique IDs so that you can retrieve them directly. And we're presenting a single JSON of metadata that's also versioned, so an immutable record of all changes throughout the history of these groups of images are being kept for you to retrieve, for you to easily update these patient demographics. And these updates, for example, patient name, if you update this concept that we'll introduce in the next slide, if you update this group of images, the harmonized metadata reflects the patient name change across all relevant objects in your data store. So going into our example, what health imaging does is it creates a patient concept called Alice. We take relevant metadata such as study date and modality, and we group images together into one AWS resource called an image set. And the image set is where you perform access control, you modify the image set metadata, you delete it, and we'll show you an example of what this looks like on the next slide. But we also have Bob, and we know Bob has 2 studies in the data store. We know he had his MR, and we do the same thing we did with Alice's CT. We bundle these together. We also know he had his pathology, and we create an image set out of all these pathology frames. In this example, this is 100,000 plus, and this is actually quite small for a pathology modality. And we give these frames a UID, as I mentioned, and here's why. Pathology is enormous, as I've mentioned. This is roughly approximating how you access pixel data in pathology. A pathologist's job is more akin to searching for a single star in the night sky, and they have to do it very, very quickly. Algorithms do much the same. So the access patterns are unpredictable. You have gigabytes of data, hundreds of thousands of frames. You need fast access. The way health imaging organizes this data is in the DICOM hierarchy, and we call this normalized metadata. For example, you can see the folded patient concept up at the top, study information, series information, and all the image frames contained within the instances are directly accessible via image frame get APIs so that you can get this data to your client fast. You can request frames in batches, and each frame is delivered to your client in about 200 milliseconds. So what health imaging helps you do is bypass file operations, bypass managing these objects DIY with your own architecture in AWS. And this service exists so that you can move faster with your application build. We want our customers to focus on exceptional patient care and differentiated features and leverage a managed service like health imaging, and we can take care of the so-called data plumbing, the healthcare data plumbing. We'll operate the foundational health data capabilities. And this is not just specific to health imaging. We have many domain-specific healthcare and life sciences managed services. For example, HealthLake for storing patient records in the FHIR format, HealthOmics for genomic storage and bioinformatics workflows, and Health Imaging for DICOM storage and low latency retrieval, and HealthScribe for generating notes from doctor-patient interactions. We lay the foundation for our partners to build on, but we offer scalable data services, and our customers, and the end customer ultimately being the patient, this is enabled by highly specialized software in a highly regulated field. We deliver patient impact through our partners. No one can speak to this better than Philips, and I'll invite Wilson Toe to the stage to speak about his part.
Thank you, sir. Hello, everyone. It's great actually to see a lot of familiar faces in this room again because it has been a long time since last year since we actually gave a talk around some of the work that we're doing across our healthcare informatics portfolio. And so happy to dive a little deeper today and really showcase the progress that the team's been making through our partnership in diving deeper into what we're doing for our patients and our clinicians that we're working with. For those that haven't really been familiar with Philips, it's probably a name and a brand that you've seen and heard, whether it's through bottles for babies or toothbrushes in your bathroom. But one thing that we're going to focus on today is a little bit more across our entire healthcare informatics portfolio. So for better or for worse, if you've been in a hospital, chances are you probably have seen and heard Philips as a brand, whether it's from a device, a modality, or even from a software perspective. I say that because the core mission that we have at Philips is to improve the lives and well-being of 2.5 billion around the world. And I say that because every single year, that's what we strive to do. And we're on the mission to do that. And we're making great progress on that. In fact, 95 of the top 100 hospitals in the US are using healthcare informatics solutions from Philips. In fact, 82% of The top 250 hospitals are also doing the same. And that spans across many different modalities that we have. So specialties like radiology, where we work with radiologists to better understand what do pixels mean and how do we help service that so that we can make their lives easier. That also crosses everything into cardiology, for example, where we work with our cardiology patch systems in order to provide visualizations and echoes, for example, with the team here actually attending and moving that to the cloud. And then, like Jared mentioned and what the team had mentioned earlier, we're also doing that in pathology. And so working with glass slides and making that fundamental shift into the cloud and digitizing that is no small feat, and that's something that we're continuing to usher in across our entire portfolio. So whether it's with pixel data or even waveform data, such as what some of our solutions in the acute care space, we're working very closely with AWS in order to make sure that the entire digital transformation in hospitals really is one that's going to change and shift the notes that our clinicians are working on together. And that we don't stop there. In fact, a lot of how we innovate is very similar to how many of you innovate and much of how AWS innovates. And it really starts with the customer and working backwards. For us, it is actually even more so with clinicians, with patients. We actually start from the bedside and work backwards from that. And that's important because it takes into account how we think and how we work with our longstanding clinical partners around the world in order to work alongside shoulder to shoulder with clinicians, with nurses, with technologists, with IT teams, with staff, and across the board as we think about what that means from co-creation and co-innovation. All of our partnerships with every single hospital and health system in the world outlast everyone at that table. And when we highlight the focus of that type of relationship and that type of partnership, it really helps crystallize the type of work that we're doing. Not so much that we're focusing on the design and the technology, but really the experiences that every single clinician is going to have as they use Philips solutions. And as we think about how that evolves over time, it's not so much that we're just running the same system in the cloud, but here's our chance to reinvent how things are being done. And that really anchors on the fact that clinical workflows change over time. And they change with the thought that things can be done differently if you have access to infinite compute or infinite storage, or the fact that as you think about how we deploy AI algorithms and AI models nowadays, it's not so much that we're augmenting existing workflows that have existed over the past 10, 20 years and just placing them there, but how do we rethink clinical workflows from the ground up with AI first in mind, with clinicians in mind, so that we can do things differently now. So I'm going to share a little bit about how we're approaching that, because these three pillars anchor everything that we do with AWS. And it isn't something that has been going on overnight. In fact, the partnership with AWS actually spans nearly 2 decades now, believe it or not. In 2008, that's when AWS and Philips started working together. And since then, we've pushed each other to innovate very, very aggressively on behalf of our customers. And so in 2014, 2015, Philips was actually the first company to launch production medical workloads into the cloud. And from there, we've actually challenged the teams to work together to think about how do we co-innovate and design differently to continue to remove that undifferentiated heavy lifting that the team was talking about in areas where they're either related to how our customers and hospital systems are accessing data, or in ways in which they're surfacing that data to run AI algorithms. And so the relationship and partnership actually extends quite a number of years in order for us to get to the point in time that you see actually on the right hand of the screen. Over the past 3 years, since the enterprise informatics business formed within Philips, we've actually moved very aggressively in order to shift our entire healthcare informatics portfolio into the cloud. In 2023, we launched our Health Suite Imaging Cloud Pack system into the cloud and migrated over 150 customer sites into the cloud. Same thing goes for pathology. We've started going down a path of trying to understand what does it mean to have these capabilities like the use of health imaging in order to think about the different types of access patterns in order to not have to worry about that on our own. And Predrag is going to go into that a little bit more deeply. And even just last week, we announced our cardiovascular workspace in the cloud as well. And so all of a sudden, our entire portfolio is now accessible in the cloud, and the cloud becomes a backbone by which all of our customers can actually engage and interact and access data differently now. And so within that space, we've pushed at least the work that we're doing in terms of the momentum in a completely different level and scale. And Jaron kind of mentioned this a little earlier, where the entire informatics stack that we have in terms of integrated diagnostics is now in the cloud. And what that means for us and what it means for our customers at that point is that 134 petabytes of data is now shifted in the cloud, and customers can do something that they haven't been able to do before, and that's access it differently and process it and compute it differently and actually transmit it differently into where they need it to be. And behind that 134 petabytes of data are 34 million patient exams that continue to grow and grow over time. So all those sites that I mentioned that have migrated over, we're continuing to work with them very closely in order to build on the momentum that the partnership has put together forward for us. And even more so, as we think about the root of what does it mean, going back to our core mission, how do we impact the lives? How do we drive and improve the health and well-being of those 2.5 billion lives annually? Software allows us to scale. Cloud allows us to scale. And behind that 134 petabytes of data are 11 billion medical records and images that help correspond how patients can be treated differently with their clinicians now. And when we take a zoom out, and Sam had this slide earlier, the medical care space is completely data-driven. And everything that I mentioned in the previous slide was all about data. It was all about bits and bytes. And we understand that behind every bit and byte is a patient. And the way that we're starting to stitch together the direction for Philips and the healthcare informatics portfolio is through that lens of integrated diagnostics, because we see a future in which clinicians are able to access and see through a single pane of glass the different type of data elements that help them make decisions easier. And so in the bottom corner that you see on the left side in that box, Sam mentioned that these are critical components as we think about modalities and how they shift into the cloud and the importance of those. That's exactly what you saw in the previous slide in which we announced those different shifts into the cloud on our portfolio. And what that means at the end of the day is Philips, as we work with hospitals, as we've worked with every single department in those spaces, all of a sudden are shifting from the work that we've done in converting biological signals into data, into ways in which we're allowing that data to transcend different data silos in order to help clinicians look at data differently now. So no need for clinicians to pull up 16 different systems to get a good picture of what's going on with a patient. With our solutions, with our direction, with our vision, with integrated diagnostics, we see a workspace by which, whether it's a referring clinician or an oncologist, for example, they're able to overlay everything on the left side of the screen. So whether it's coming from radiology modalities or coming from pathology scanners, for example, all that is able to be overlaid into how clinicians can look at patients differently. And so that fusion of data actually drives a different type of discussion, not only between clinicians as they're working to figure out what is the best treatment plan and approach for their patients, but also the conversation between clinicians and patients. And with that, we think about how therapy can be done differently. We see how we can equip and enable clinicians to rethink how data-driven imaging modalities can convert into really different treatment plans. And so with that in mind, we think about how whether it's patient surveillance and monitoring at home or in the hospital, it all comes together to rethink of how our clinicians are behaving and operating in the hospital today, and more importantly, the future that they have going forward into the different spaces within radiology, cardiology, or even pathology. And with that, I'm going to invite Predrag to come to the stage to go a little deeper into specifically the pathology space, and we'll go dive into how we're approaching our journey to the cloud, and more importantly, how we're looking at integrated diagnostics. Predrag.
Thank you, Wilson. Hi, everybody. First of all, an apology. I'm a little bit sick, so if my voice kind of gets raspy or I cough in the mic, I apologize. My name is Predrag Angelovsky. I'm the CTO of Philips for Healthcare Informatics, and I would like to take some time today from you to talk about Integrated diagnostics, what does it mean and how does it actually affect both the work of hospitals, patients, and the future of precision care? Then dive in a little bit deeper into our pathology solution, and then explain how AWS HealthImaging actually helps us remove some of that burden that my colleagues were talking about and really focus on clinical value and clinical innovation. I will talk a little bit about the architecture of it and then explain why can we focus doing what we do, and that is providing the best tools for clinicians to actually help patients, rather than be burdened by questions regarding where do we store the data, how do we manage the data lifecycle, how do we keep hot versus cold data. So with that being said, first I would like to take a moment and talk about integrated diagnostic, because I think it's a word that you've heard many times here, and on the surface, it's a very simple thing. When you think about integrated diagnostic, you're thinking about, oh, it's a system where a bunch of solutions work together. But when we really think about integrated diagnostics, we don't need to think, and we shouldn't think, as a system where radiology, cardiology, digital pathology work in semi-isolated silos stitched together by point-to-point integrations and data movement. When we talk about integrated diagnostic, we really have to talk about all of these disciplines that come together in a unified fabric to provide a longitudinal view over a patient with the radiology data, the cardiology data, the pathology data, but also data from any other imaging modality. Digital pathology is the key fragment that brings this all together. Just as an example, 70% of imaging decisions are made based on digital pathology data. 100% of tumor or cancer diagnosis requires some level of digital pathology in order for a proper diagnosis and treatment to be defined. Yet pathology was the last of the ologies to be digitized. Radiology digitized decades ago, cardiology soon followed. But pathology was always seen as difficult and cumbersome. And thanks to the presentations of my colleagues, you can understand why. A pathology slide is 10 to 20 size the radiology study. The slides are big. There was simply not proper architecture and proper resources on-premise in hospital to build a solution like this. Recent advancement in technology, and specifically in cloud, have made it possible for us to develop a digital pathology solution. And with it joining the fray, we finally can build a proper integrated diagnostic solution. Now, what does this mean for a hospital? What does this mean for the work of the clinicians? Well, in any of these layers that are on the topic, there is a certain impact that is different than the way that things work today. If you look at the workflow layer, today, if you would like to bring and see images from multiple disciplines, you're dependent on either operating different systems, taking screenshots, either doing printouts, or sharing data offline in different reports. By having a unified viewer that allows you to see radiology and pathology data next to each other, clinicians can drive better information and make better decisions. If we look at the workflow layer again, you can have now workflows across ologies. You can have triggers in digital pathology being sent directly to a radiologist or to a physician that is then going to perform the following task in that thing. Today, that is all either a very cumbersome and error-prone point-to-point integration or a manual step of passing patient records or notes around. One of the big important pieces is also in the infrastructure. Instead of managing 4, 5, 6, 7 different solutions, different upgrades of software, different database upgrades, different standards, different networking requirements, now you're going to work with one integrated solution that is much more easy to manage and it's much more easy to operate. And finally, data, and this is the most underestimated thing. Today, data lives in silos. Radiology data lives in the PACS. Cardiology data lives in the cardiology solution. Pathology data, if it's digitized, lives in its own solution. If you would like to do any meaningful research, if you would like to do many meaningful AI models, especially across modalities, you are really dependent on copying that data. You have to bring that data from multiple sources into one new location where you're actually going to be performing those operations. With integrated diagnostic, the data is in one place, and not just the data, but the metadata is in one place. It is all connected. It is all well described. It is all predefined. So things like training multimodal AI models becomes much easier because the access to the data is there. Now, before I go into explaining what Philips Enterprise Pathology Solution is, I would like to take you to this slide that I kind of call, ironically, the story of the slide. I think as Jeroen previously or somebody of my colleagues mentioned, a slide is a piece of glass, which after a biopsy, the technician or pathologist puts the sample on, smears it together, and that becomes the single truth for that procedure. If the slide is damaged, everything is gone. If the slide is exposed to higher level humidity, it is gone. So that slide is literally the only proof of any finding or anything that happens down the process. Once the slide is taken, especially in manual pathology, you have to prepare that slide. Every slide has to be hard labeled, which is the patient, what it is. Of course, it's not all on the slide, but it's labeled with a reference. Then it's quality control. Has the slide been properly smeared? Does the sample has been properly prepared? Then after that, it's probably all loaded in a trolley. And when enough slides are there, it gets moved to the next step of the process. Then comes the work of the pathologist. The work of the pathologist today is looking through a microscope, trying to find a needle in a haystack. And they're extremely good at this. However, it is still a very difficult and tedious job. Not just because it's difficult to find the parts that are interesting, but also they cannot write a report at the same time that they're doing analysis. So they take notes, either mental or written, and then they continue the analysis, constantly zooming in under an electronic microscope. They do measurements manually or, well, supported by electronic microscopes. And then finally, they have to write a report. So all the work that happened before, all the notes they've taken, everything that they remember that they saw, they write a report which is not connected to the image. This is, as you can imagine, not just potentially error-prone, but also not very efficient. Digital pathology changes this in a very fundamental way. The moment the slide is smeared and ready, it goes into a scanner. These are high-performance scanners. And the moment the slide is digitized, it becomes part of the cloud-native imaging fabric. It's enriched with metadata. We have AI-assisted algorithms that start the automatic measurements and measurements taking. There are other Philips and third-party algorithms that help with dyeing, that help with identifying and categorization, and even algorithms that do automatic pre-quality control. So that means that even before the slide reaches the next step, which is the quality control, a lot of work has already been done on the slide to help the technician and then the pathologist following that to actually perform their work. Quality control becomes verification of previously done AI-assisted control. And then the work is immediately, instantaneously available for the pathologist. I say instantaneously, let's say near instantaneously. There is always some time that takes place. The pathologist's work is the one that is, I would say, most impacted in a positive way. Instead of zooming in and out on a microscope, they're looking at a screen of a high-resolution image. Thanks to AHI, they're able to pull in slides, focus on specific areas, and easily switch between different areas of the slide. Not only that, they can take bookmarks. They can add notes. They can write the report in parallel to the slide. Not only are they writing the report while they're looking at the real source of data, but thanks to bookmarks, finding in that report can be linked directly in the slide. So when you're reading the report, because it is all running on the same platform, you can actually click on different bookmarks and directly zoom back to the source of truth. And finally, efficiency. And this is what we were saying all along. In a very strained healthcare system, every minute counts. An average manual digital pathology workflow, and keep in mind this is an average from multiple surveys, it's about 11 hours and 35 minutes from slide to report. A lot of this is because there is a manual movement of the slide, manual notes. You have to gather a bunch of slides to move them forward. In digital pathology, this goes down to 36 minutes. This is a very important time save, not just for pure sake of efficiency, but this means that now pathologists can handle more cases and help more people, reducing the time between sample taking and the potential diagnosis. And specifically in pathology, every minute counts. So what is Philips Enterprise Pathology Solution? I think it's important to notice that Philips Enterprise Pathology Solution is not a software. Philips Enterprise Pathology Solution is a full solution from slide to report. We produce a high-performing scanner that generates a DICOM whole slide image in under a minute. Then that is integrated with our backend, where we support a fully automated workflow and work list that allow people, based on rules or on AI algorithms, to then move this data to the next proper steps. We have AI algorithms for automatic quality control, measurement, but as well as pre-diagnosis and categorization. It is fully integrated with other laboratory information systems and EHRs. And then finally, it is integrated with, and I'll talk about it in a bit, with other systems where you're able to use this data to train AI and to deploy it back into the system. It is a cloud-native solution. It is built fully on AWS. And thanks to our partners, I believe it is the future of precision diagnostic and of digital pathology. To talk about the architecture a little bit, going back to the slides and what everything that Jeroen presented is important for us. I'll focus on three things: ingestion, storage, clinical diagnosis and review, and tumor boards and secondary clinical use cases. So ingestion. As I said before, Philips has a very high performance scanner. This generates a whole slide image in under one minute. This doesn't say a lot. But when we compare that to the numbers that Jeroen was showing, we end up with almost a gigabyte of data per minute, per scanner. Hospitals run 10+ scanner. That's some hospitals. They could be multi-site, there could be thousands of hospitals in our ecosystem. We need an architecture that is able to scale and be able to ingest all of this. That is why we've decided to partner with AWS AHI. AHI removes that whole burden of ingestion from us. We stream the data directly in S3 buckets, from which AHI actually consume the data. If you're wondering why the S3 bucket in between when AHI actually has a DICOM web interface, well, for the size of data of pathology, it's actually better to stage the data in the cloud first, because data can get corrupted during transfer. Metadata can be changed, metadata can be corrupted. So if something happened during the scanning of this slide image, it's better for us to have the data in one place where we can figure out what happened than to go back through the hardware, look where it is, re-upload it if it only requires, for example, a metadata re-upload or a metadata fix. The other important part is the lifecycle management. AHI actually provides a full hot and mid-tier storage for us. That means it makes sure that the image that we need is always available to us at the highest potential speed. I'll go a little bit into consumption in the next thing, but one of the larger problems when you're dealing with data of this size is you never know when you're going to need what image. If you try to store them all in a very hot storage, it's very difficult. They're large. It gets expensive. AHI removes that problem for us. It adds an abstraction layer in which we can request whatever we want, and we always get it with a specific amount of speed. Finally, thanks to other AWS services, we've actually designed the rest of our solution to be fully stateless as well. Most of our logic runs on containers. The rest of it runs in Lambda. And we use Aurora serverless for some of the patient metadata storage. This means that with our partners from AWS, we are designing and building a system that is virtually endlessly scalable. And this is important because not only is the data large, but the number of patients is increasing. We need a system that is going to not just be sufficient for today, but also for tomorrow and for the future. Now, on the clinical diagnostic and review, there is, I would say, two important pieces. And I briefly touched upon them, but it's good to go back. One is actually consuming of tiles. And tile is what Jeroen referred, if you remember, when you look at that whole slide, there is these tiny boxes that represent zoomed-in images that are all indexed by AHI. We can request any slide, any tile from any slide and get a sub-200 millisecond response. That means that the pathologist can literally click through a slide at any speed and never notice any latency of images loading. The other part is, and again, I'll go here on the lifecycle management of things. Once we upload the slides into AHI, we upload the metadata. After that, AHI makes sure it's moved to proper tiers of storage. It also, thanks to other AWS services like Glacier, we can also decide to move this data into an archival storage. Because the thing with pathology data is it's important when it's hot, when a diagnosis is made, but it also becomes important at points in the future, when people want to evaluate. Has this tumor progressed? Has something changed? Has it grown? Has it developed new features? So data is always important, but holding that amount of data in hot storage is practically impossible. Thanks to AWS and AHI's integration with other native AWS services, we are able to design workflows that smartly move the data to different storage layers, such as S3, AHI, and then Glacier for archiving. On the clinical diagnosis part, and this is also extremely important, because of the integration of AHI, like I said, with things like STS and EIM, we can have zero footprint viewers, meaning clients don't have to install software. It's all web-based. Our software goes directly towards AHI to fetch these images. This is important for a few reasons. If you're focusing just on digital pathology, it is important because it allows real-time access to that data to multiple pathologists, so they can collaborate in real time. Because it's cloud-based, it actually allows pathologists from different regions to collaborate with each other. A pathologist from the US can actually go and look for advice from a pathologist in the Netherlands. Instead, if we want to do that today, you actually have to ship the physical slide. You can send screenshots, but then you end up on, can you send a screenshot of that? Can you take a screenshot of this? Can you zoom in on this region? But if you would like to get a second opinion, you have to move the physical slide. With digital pathology in the cloud on AWS, we make collaboration between clinicians seamless and effective. And in the integrated diagnostic workspace, this same thing allows us to have radiologists being able to look at pathology data, cardiologists being able to look at pathology data. And I go back to pathology because radiology gives us an image and pathology gives us the truth. You can see a misshapen cell or a tumor, but until you do a biopsy, you don't know if it's cancerous. You don't know what Bethesda stage it is. Pathology is the glue that binds the entire integrated diagnostic solution together. Finally, and this is important, tumor boards, and I'll also talk a little bit about research. Tumor board is a process where specialists from different areas meet in an offline meeting. They bring all the patient record together, and then they discuss the findings to determine what is the best path forward for this patient in terms of treatment, in terms of further diagnosis. Today, a tumor board is an offline meeting, meaning you bring the data you have and that you think is going to be important. Now, you could forget data. You could take the wrong images from the slides. You could get questions that you're not prepared to answer because they're not in the report. In digital pathology, tumor boards become fully online, fully digital, fully enabled. Thanks to bookmarks in the reports, we're able to zoom into the slides. Thanks to the digitization of images, we're always looking at the same source of truth. And last but not least is research. Having the data in one place and not needing to copy it in multiple separate locations is what distinguishes AWS HSI for us. Connecting that with other systems, such as SageMaker, for example, allows us to bring that data, train or specialize a model, evaluate that model, and then deploy it back in the solution without having to worry of where that data resides and manage that. So what does this mean for the work of pathologists? And this is based on a survey of 52 pathologists, lab agents, and things like that. And I'm not going to go through the whole thing. I know everybody is kind of eager to end the last session of the day. So 100% of the surveyed pathologists do not want to go back to a microscope once they experience digital pathology. There is about 21% more cases diagnosed in digital versus manual pathology. 100% of pathologists have claimed in this survey expressed that digital pathology helps them reach diagnostic consensus thanks to enabling digital online collaboration. Last but not least, I hope that from what we have all talked about and what we have all shown, you understand that this is a very complicated topic, and it's a very complex area. And in a complex area, you cannot do everything by yourself. It's all about partnerships. Sam started with partnerships, and I want to end with partnerships. Philips brings our clinical expertise and our clinical knowledge, our knowledge of operating in highly regulated environment. We bring our partnerships with hospitals and clinical institutions. We bring our years and years of tradition of innovation. AWS brings us a secure, scalable environment, then continuously keep on innovating. They bring us the storage we need. They remove the complexity from our life and allow us to focus on what we are good at. And that is why these kind of solutions are only possible through real partnerships. With that, I want to thank you for your time. If you have any questions, we would be happy to answer them, and we look forward to seeing you around. Thank you.